some trig identities can be established by factoring, and this is an example of a case where this will work. So remember, my goal is to rearrange one side to try to end up with the other side. In this case, I'm going to make this my goal, so I'm not going to mess with that side. I'm going to rearrange this side over here and try to end up with sine of v plus 1 over tangent of v, and then I'll have established the identity. So let's try to do this by factoring. In the numerator, I see sine squared of v minus 1, and right away I recognize that as a difference of two squares. Something you may have factored in the past may have looked like x squared minus 1, two terms that are both perfect squares and they're being subtracted. So I can factor this similarly to how we'd factor x squared minus 1. It would factor into sine of v plus 1 and sine of v minus 1. Okay, the only difference between those two parentheses is one's plus, one's minus. Let's go ahead and try to factor the denominator of this fraction then. In the denominator, what I notice is that both pieces have a tangent in them. So again, as we compared before, maybe you'd see something that looks like I don't know, maybe something that looks like this, and you'd recognize that, hey, there's a greatest common factor in there. So in this case, with trigonometry, I still can do greatest common factors. They both have that tangent of v piece, so I'm going to factor out tangent of v. And what's left then when I divide that out would be a sine v from the first term. And then when I take tangent of v out of itself, or if I divide tangent by itself, I end up with just 1. Okay. Now that everything has been factored, I'm free to cancel anything that might be the same on top and bottom. And so right away I notice that I have a sine of v minus 1 over a sine of v minus 1. So those pieces can be canceled out, which leaves me with sine of v plus 1 over tangent of v, which I believe was the goal I was trying to get to. And so I've made it. I've established that identity.